and welcome to tutorial number 25 of series of 2020, where we're going to look into origami folding, and it's going to be a straight line, your typical origami folding with Grasshopper. But I thought to kick it up a notch and actually try and do something that is used in reality. And I started looking into these cool origami patterns that NASA is using for their spacecraft. And I came over this guy right here, which is a Starshade pattern that NASA is using for, unfolding. I assume those are... how are they called? Photovoltaic panels. So we're going to try and do precisely this. For that, I am going to create... actually, I'm just going to borrow... Let's say this one is a bit better. I'm just going to borrow this image right here, just copy it, and I'll just paste it on my reference sheet right here. Okay, so to start things off, we don't really need to use Grasshopper from the get-go. I will start with Rhino just to draw out this this pattern, because it needs to be a mesh, and this needs to be the topology of the mesh that we have, right? So first I need to analyze it, and actually I've already done it, kinda. This pattern is made out of 4 or 3 different parts: the inner circle, the outer circle, or rather the inner polygon, the outer polygon, and these beams or whatever right here, these radial beams. So let me grab a lower version of it. Maybe this one. I'll just grab this one, copy image, paste it here as well, just to be able to look at it properly. So this is a highly simplified one, but we're going to do something in between this dense one and this simplified one. This one just lets me understand the principles of the form a bit better. Okay, so enough talking, let's start drawing. First thing is I'm going to draw the inner circle or inner polygon and outer polygon. The outer polygon will need to always have 2 times more points, 2 times more corners than the inner one. So if this is a hexagon, this one needs to be a 12-sided polygon. To do that, I will just grab a polygon tool. I'll start drawing from 0, so I just hit 0, enter. And then here in the command line, I just choose number of sides, and I'll go for, instead of 6, I'll go for 8, something like that. And I'll make sure that orthographic snapping is turned on, and I'll just drag it out like so. Okay, so we have an octagon here, and I don't really care about the radius of it. I'm just kind of winging it. All right, so we have an octagon. That means that the outer, the large polygon here, the outer polygon needs to be 16-sided, so it needs to have 16 sides. I will start creating a polygon again. So with that polygon tool, hit 0, enter. So I start drawing from 0, and here number of sides, I'll just go for 16, enter, and just drag it out like so. Something like that. All right, so we have the small one, we have the big one. Maybe the big one can be even bigger. I don't know. We'll see. And now we need to see the relation between them. So notice how, if I look at the corners, this point here and this point here, these opposite corners of this outer polygon here in the reference And these inner two corners, they're not on the same line, right? This one is slightly rotated clockwise. And I don't know the value by how much it's rotated, so I'll just wing it and I'll just try rotating it by minus, let's say 10 degrees. So we're just kind of rotating it by 10 degrees clockwise. Okay, so we have the inner one, the outer one done. Now I'm going to draw out, or rather I'm going to analyze how these radial, no, these are not radial, how these beams going from the inner one, from the small polygon to the outer one, how those are arranged. You can see that every point here, every point has two beams going from it, right? Okay, so that's the first thing. The second thing is that every blue line makes a break. So it's hard to explain here, but notice how when you have this kind of red line going out, red beam, the lines crossing it, they stay on the same direction, so to say. While the blue lines, they also break the direction, so they always make a turn. So as the lines are crossing the blue one, they're changing the direction, while the red one doesn't influence the direction whatsoever. So I'll start off by drawing this blue line right here. And since this one is a hexagon and we're playing around with the octagon, I'll just guess from which point to which point I need to draw. Maybe this one, this higher resolution one, will help me. Oh God. Yeah, that's not gonna that's not gonna help me at all. I'll just say that perhaps it's going to be let me try to analyze it. We're going to go much faster once we figure this out. So if this one is here, maybe it needs to go until here. Yeah, let's try doing, let's try saying that this point connects with this one? No, with this one. Maybe. Sorry, I'm just I just don't want to make a mistake right at the start. If this one connects with this one, then that means this one connects with this one. So we just have that small gap there. Maybe that's enough. Okay. So I'll just say that the furthest to the right one, this point right here, connects to the top one here. Okay, but then you can see that these beams, and I'm just drawing one because, you know, it all can be arrayed. Then you can see that these beams are also bending, right? So I will select this line here and I will rebuild it. And I will rebuild it with point count of 3 and degree of 2. Meaning that it's going to be an arc, right? With a single center control point. I hit OK. I hit, or rather, let me just type in points on, enter. I grab the center point here, move it, enter. And I just move it along the beam to somewhere, let's say, somewhere here, like that. And now what I can do with it is I can, since I still have that point selected, I can rotate around the center point. So around point 0, 0, 0, I can rotate it by, let me turn off ortho for this, by some amount, right? And I don't know what kind of amount it is. And now I can see that, oops, now I can see that I moved this point a bit too far down, so it needs to be actually somewhere here. Let's say 1/3 of the way down. Again, rotate around 0, just slightly, like that. I think that's gonna do the trick. Yeah. Okay, so now when we have this line drawn out here, let me actually rotate, not rotate, array polar, meaning around some sort of a center point. We're going to array it like a clock. So center of polar array, I'll just say 0 again. So we're doing everything around 0. And number of items, well, that's how many points we have here, and we have 8. So I just type in 8, hit enter, and keep hitting enter until it stops asking me questions, and I end up with something like this. All right, so we have that done. And now the next step, well, and we are getting closer. The next step is to actually figure out these radial spiderweb lines, right? And how those are arranged here. So you can see a line starts from let's say this point here, right? It starts a line, and it goes until our first line segment, until our first blue line. And actually I probably should color code this. So let me make all of these guys layers, and I'll just create a new layer, call it blue, and make it blue. Change object layer. There we go. So all of these blue lines right here are indicating where this kind of spider web line breaks, right? And red lines don't really indicate anything, but red lines seem to be going kind of close to the center point of these lines, but also then they don't really follow any rules. We'll fix the red lines a little bit later. For now, we're just working with these ones, with the blue ones. All right. So we need to make these spider lines here, spider web lines here. To do that, I will first of all decide on how many points. Look at this blue line here. How many points will my blue lines have, right? So here there's like 1, 2, 3, 4, 5 points, and come on. And here we have, I'm not gonna count that, but more than 5 points, right? So I will go for, I'll just select these guys, all of them, and I'll type in divide. That's not how you type in divide. Divide, enter, and I'll choose, yeah, I guess let's go for 14 points. There we go. So we end up with, you know, this amount of points on each line. And you would think that, oh crap, now we need to actually draw all of this out. Not necessarily. We just need to draw out one, you know, one polyline like so. We just need to draw that one out, and then we can again array polar to make all of them. So I will just draw out one, and for that let me just create a new layer and call it long polyline, whatever, long polyline. And I'll just make it green, I guess, like that. And I'll start drawing. Okay. So let's say that this is our starting point. So I go from here to here, and then let's investigate. This is a shitty one. Okay, so we go from, let's say from here to here, right? And then we need to go to here. And you can see that while this point is the first one, this is the second one. And then afterwards, this is the third one, right? From the start, right? And then the fourth one and so on. So that means it keeps increasing the gap of points. So while this one is the first one, this is gonna be the second one. This is gonna be the third one. This is gonna be 1, 2, 3. The fourth one. 1, 2, 3, 4. The fifth one. 1, 2, 3, 4, 5. Sixth one. 1, 2, 3, 4, 5, 6. Seventh. 1, 2, 3, 4, 5, 6, 7, 8. And then I'll just kind of count how many are left. 1, 2, 3, 4, 5. So that means we need 4 left. 1, 2, 3, 4. And then the fifth one is here. And don't mess this up. Of course, when you use polar array, you will notice if you messed up the spiral. So that's 4 left. That means here we need 3 left. Here we have 2 left. Here we have 1 left. Up. 1 left. Here we have 0 left. And then what happens when there's 0 left? Right? It just goes to the corner. So it just goes like that. Okay. We did the spiral. So now I don't need the points anymore. I will type in cell PT to select all of the points and hit delete to get rid of them. So now let's see if we messed up the spiral or if it actually worked. I will select it. I will type in array polar. Let me actually just mute the other computer real quick. There we go. So array polar, center of array, 0, enter. Number of items, 8. Is it 8? It starts from every corner of the inner polygon, so it is 8. Number of items, 8, enter, enter, enter. Doesn't seem like we messed up the spiral. Looks good. Okay, so we have almost done the pattern. The last thing to do is to actually I guess, just draw out a line similar, like I'll just go by the feel. So I will just create a new layer and call it red, whatever, there. And in this layer, I will just try and draw out from here to here. We have a line, right? Because I'm kind of looking at this line, this blue line here, and I can see that the red one sticks out from the blue one, like so. So we have a line going on here. I will rebuild it as well with 3 points. I will take that center point, move it. Come on, move it. Enter to somewhere, let's say 1/3. That's 1/4. Let's try 1/4. Somewhere here. Rotate around 0. So I'm doing exactly the same thing as with the blue one, as with the blue line. And I will just try to make something similar to what I see here. So this seems to be okay, right? Let's keep it. Okay, so we have that going on. Super. And then I will just array polar this bad boy here around 0, 8 times, enter, enter, enter. We're done. We have the pattern. Should I keep? Yeah, I'll keep this reference here, or rather, let me actually close this. No, don't save. We have the pattern. Now, time for some Grasshopper. By the way, don't mind this part here. This is my notes, you know, to if I mess up, to just keep going. I'll just check it out. But basically, the first step is to get rid of all the layers. I'll just create a single layer and I'll call it, or rather rename the default layer and call it curves for mesh. Curves for mesh, and I'll select all of the objects in other layers and just change object layer. So basically I'm just moving everything to curves for mesh, and then I'll just delete Yeah, I'll just delete everything else. Every other layer. Okay, so now everything is in a single layer. Let me reference them into Grasshopper. CRV, 222. We all know this by now. Set multiple curves, set all of them up. Super, we have them. Now we need to make them into a mesh. Well, not that easy, right? You could technically start constructing a mesh in Rhino, but that would take way too long. Well, honestly, not that much, because you only need to construct 1/8 of it and then just polar array it, but still, this is going to be faster, and also it's going to kind of let you just draw curves and create a mesh any way you want. For it, we will use Weaverbird. And in Weaverbird, under the left-hand side, you can see Weaverbird's Mesh from Lines tool transforms a list of lines in a mesh. This component is experimental, we don't care. Okay, so we will be using this one. The problem with it is that if I connect my curves now into it, it's not going to work, because we have curves, we have polylines, we have polygons, we have all sorts of shit here. And we actually need everything to be separate line segments with 2 points, starting point, end point, right? So, which means that, first of all, everything needs to be exploded, but not just exploded. For instance, this guy right here needs to be made out of straight line segments, right? Separate straight line segments, which means that everything needs to be split apart, right? And to do that, we don't need to do it in Rhino. Again, we can do it here in Grasshopper. To do that, I will be using a tool that's called Shatter, somewhere here. The problem, and actually I can probably do that. The problem with Shatter is that it requires me to give it a parameter to split at. I don't have parameters, right? So I need to get them. And to get the parameters, we need to use an intersection, first of all, where we will say solve multiple curves intersection. Solve intersection events for multiple curves, blah, blah, blah. So I just give it a bunch of curves and it gives me a bunch of points, right? Okay. That's cool and all, but that's definitely not, you know, that won't work. I can connect it, but it's going to freak out. Okay, so we need to somehow convert these intersection points, which we all have here, into curves. Into parameters. So to do that, I will be using pull point. Is it pull point? And this is where I check my notes. No, curve. We will not be using pull point. We'll be using curve closest point. Sorry about that. Curve CP, curve closest point, and all of these points will be measured how close they are to each curve. And here it's not measuring each curve, here it's just measuring the first curve. To make it measure each curve, we need the curves to come in separate lists, in separate data tree branches. And it's quite easy to do. You just right click on the curve input and choose to graft the curves. Okay. So now all of the points that we got are being pulled towards each of the curves, meaning that we get a shit ton of curves. But that's fine. We don't care about the point output. We do care about the parameter output, because right now we start getting the parameter. The problem is that we're getting way too many. So a trick is to ask for distance. Is the distance which we're finding the closest point, is the distance larger than 0, right? If it is, that means that the point, the intersection point, doesn't belong to the curve, right? Meaning that it should be ignored. So what we're going to do is we're going to ask, is the distance smaller than something small, 0.001 or 0.01. There we go. The reason why I'm not asking is the distance equal to 0 is simply because Grasshopper and Rhino works with tolerances, and sometimes it's not exactly 0, so it starts making mistakes. So I'm just asking, is it smaller than 0.001? That's fine. And by the answer that we get, we will cull out or remove these parameters here, right? If it is larger, the parameter will be removed, right? Meaning that the parameter doesn't belong to the curve. All right, so we have a bunch of parameters here, but they come in as a data tree. And we have a bunch of curves here that don't come in as a data tree to the curve shatter. So we need to either flatten out the parameters, which will not work, or graft the curve input here as well. So I'll just, of course, graft the curve input, right-click, graft, and now my curves come in as a data tree, every curve in a separate branch, and all of the parameters that belong to those curves also come in separate branches, meaning that these two objects or inputs, they talk to each other properly. All right, so now we have a bunch of separated curves, which we can just flatten out, meaning, right-click, flatten, meaning that now all of them are in a single list and all of them are now split, right? So, like that's a single segment, that's a single segment, and so on. The problem is that these segments are still curved, so I want to fix that, and it's very easy. I will just say end points. So I'll just grab the start and the end of each curve, and I'll just draw a line between 2 points, between start and end points. And now I have straight line segments. And now, moment of truth. I will try to connect them to Vierbird's weave component, because now all of them are separate line segments, just like this guy is asking me of. Voila. Works perfectly. Okay, so all of this part, I can actually group this, and I'll just call this curves to mesh. And we have our mesh here as an output. Actually, can I just create a new layer here? I'll call this helper, and I will hide these curves here. I don't want to see the curves anymore because we have a mesh now to work with. Super. Next up, we want to start fiddling with it, start being able to fold it. Let's look at the fold lines for it. Or no, let's first set up our Kangaroo script. So mesh comes out here, so I'll just create a mesh component here, like that. And then I will start working with Kangaroo portion, the simulation portion of the definition backwards, right? Because that's, I don't know, for me it's much easier to work that way with Kangaroo. So I'll go for Kangaroo 2, I'll go to main, tab here, and I'll choose solver. That's the brains of the simulation, right? And within the solver, there are 2 or 3 constants, right? On or off switch is always a toggle, Boolean toggle. I'll keep it as false right now. Reset button is always a button. Threshold tolerance, we don't care about those 2 inputs. Goal objects, I always use entwine. Just because I like my geometry to come in as 0, 0, and all of my goals for physics simulation to come in as 0, 1, because it's much easier to then extract it. And actually, let me elaborate on that. So 0, 0 will have a goal that is called show, right? And that show goal will be showing a mesh. We'll be showing exactly this mesh as it's being folded. And I can just kind of connect it like so that the solver doesn't complain. And everything else that happens with the mesh, what can we do with it? Can we add gravity or something? Nah, it doesn't matter. Everything else that happens with this mesh, all of the other goals, anchor goals and so on, will come into 0, 1, right? I'm doing this because then after the solver has kind of thought about it and finished processing, the output will also come out as two separate branches, data branches, and I can explode that data tree with bang, explode data tree, and I know that this output right here is going to be my mesh, like that. That's it. That's the whole setup, right? Well, right now, if I run the simulation, it's going to be kind of boring because it's just going to be, you know, show the mesh. Kangaroo goes like, here you go, and I go like, cool. No goals whatsoever except for show. So that's not a very interesting simulation, but it is working. So now let's make it interesting. Origami folding. Okay, so finally we're at the actual tutorial. There are two ways of how you can fold a piece of paper, I guess. And where was it? Yeah, there we go. There's the mountain fold. Can I make this bigger? Hello? Ah, no. Open image in new tab. There we go. Then there's the mountain fold and there's the valley fold. Mountain fold means that as you're folding it up. Valley means you're folding it down. Easy. So let's do that, right? Why not? Before we do it, we need this mesh to behave like paper, somewhat like paper. So I'm going to be doing a few things to it. First thing is we need it not to be stretchy, right? We need all of these lines, all of these edges to try and stay the same length. And for that, I will be using goals mesh edge lengths. Like that. Mesh connects to mesh. And these come into 0, 1 input here, right? Because 0, 0 will only have the show. Length factor, I believe by default it's set to be, length factor of 1, meaning every edge will try to stay as it is. And that's perfect for us. And we actually want this to be pretty strong. Right now the strength of it is set to 1. I will say, I don't know, 100? Let's try 100. So it's a pretty damn strong goal. Definitely don't deform. All right. So now, sorry, I'm thinking. Now we can start folding, and then you'll see how it messes up. So let's start folding. To do that, we need to go to mesh, and we need to, goals mesh, and we need to choose hinge. Hinge tool right here. Hinge tool, and hinge tool or hinge goal asks us for 4 different inputs: fold start, fold end, tip 1, tip 2. And before it was pain in the ass to set everything up, but now Kangaroo has a really nice tool that's called hinge points. It's under it's under mesh tab, not goals mesh, but mesh tab. It's called hinge points. Right here. Basically, you just plug in any mesh to it, and then it gives you 4 outputs, and you just do this. 1 goes to fold start, 2 goes to fold end, tip 1, tip 2. Just like that. Basically, then you just describe a hinge, right? So first 2 points are describing the line around. Think of a door. So first 2 points describe or two-sided door, two-fold door. First 2 points describe the axis around which the doors rotate. So because it's a line, right? And other 2 points describe the this tip right here, you know, for the door, and this tip right here, right? Okay, and then we have rest angle, which is in current angle will be used, and the rest angle is in radians, I believe. So I will create radians node, because I like to give an angle in degrees, and my angle is going to be between 0 and 150, let's say, for now. Okay, so we have that going on, and I can just connect it to my 0, 1 input again. Hinge connects here, holding down the shift key. I just connected. And let's see how it just destroys the mesh, I guess. Let me disable preview of this, reset, run it, and start folding everything. Actually, it's pretty cool. It's starting to mess up a bit, vibrating. Yeah, so it's not, you know, it's not nice. That's because we're basically trying to fold every single polygon, right? So that's never gonna work. This is why we have in Origami these mountain fold lines and valley fold lines, and they are precisely where they need to be. And to do that, I need to be able to work with that, I need to specify them in Rhino, right? Or both in Rhino and later on in Grasshopper. So let's do that, shall we? I will bake out this mesh that I got as a helper. I'll just bake it out, and I will create two new layers. Layer 01, I'll just rename it to mountains, and layer 02, I'll rename it to valleys. Okay, so we have mountains and valleys, and let's say mountains are blue, valleys are green. Okay, mountains are blue, valleys are green. Super. And I'll just go to top view. I'll grab I guess a polyline tool, and I'll just draw out a single line for the mountain fold, which is where the spider web line makes a turn, while the valley fold line is where the spider web line doesn't make a turn. Okay, so that means this line right here is a and make sure that as you're drawing out the polyline, you have vertex snap turned on so that you can snap to the vertices of the mesh. It needs to be pretty damn accurate. So that means that this line right here is a mountain fold line, while let me change layers. This line right here is a valley fold line. So I'm just clicking on every vertex along the way, because all of these will need to be exploded as well. And I'm using a polyline because after I explode it, I want all of these curves to be straight line segments. Okay, so we have the mountain line and the valley line, and I will just select both of them, use array polar, round 0 point, number of items 8, enter, enter, enter. And now I have all of my fold lines here. Before I finish, I will just select the mesh, get rid of, like delete the mesh, select all of my curves here and type in explode. So that every, every curve is was exploded. So now let me reference them in. I will start by just creating two components, curve containers here. Curve, let me just copy paste it, curve, and I'll just call this mountains, and I'll just call this valleys. Okay, we have that going on. There we go. So now I'll just right click on my mountains layer, select objects, right click on the mountains component, set multiple curves. So now I have referenced in those curves here. And I'll do the same thing with the valleys. I'll right click on them, select objects, make sure that everything is unselected before you do this. Select all of the valley lines, right click on the valleys, set multiple curves, good to go. Let me jump back to helper as my active layer, hide both of these. Yeah, that seems to do the trick. Okay, so I have my mountains and the valleys, which means that only around these curves should there be bending. Everything else should be kind of, papery. It's not a fold line, right? So it's not actively bending. So how do we work with that? Well, first of all, I am going to how do we work with that? Okay. So first of all, I'm going to actually visualize where the fold lines are in this mesh by typing in line between 2 points. And as I said, first and second point is the axis for folding. So I'll just connect these two here. And you can see these are all of the axes for folding this particular mesh. It triangulates it for you. Okay, so we have that going on. And now I need to, out of all of these, I need to know which ones of these lines are underneath the mountain fold lines here. I'll come back to valleys in a bit. So which ones underneath are under the mountain fold lines? I can do that by asking for the center point for these line segments. So evaluate length at 0.5, or actually let me just write it in a panel, 0.5. So evaluate length will give me, half the length of each of these lines. Okay, and I can do the same thing with the mountain, segments that I have prepared here. Also evaluate. No, that's not how you do it. Also evaluate it, every segment at 0.5, which means that some of these points are above each other, right? Like duplicated points. And I can find which ones they are by using pull point component, pull point, and saying that every single one of these points here should try and pull the closest one from this list right here, right? And give me a distance. And if the distance is smaller, than, let's say something small, 0.01 again, we're working with tolerances, meaning that I can't just do, is it equal to 0? So if the distance is smaller than 0.01, it should give me an answer true. If it's not, it should give me an answer false. And we can use this output to cull. So we're using this as a pattern to cull And what do we cull? Well, first of all, let's try and cull these lines to see if it works or not, right? So I'm culling all of these lines, and I can see that after this check here, after we cull the lines, we only get the line segments underneath these mountain lines here. That's perfect. But it's not actually these ones that we want to cull, not actually the lines. It's the goal itself, the hinge goal itself, the hinge goals that we want to cull, right? So I connect hinge to cull L input, and then disconnect it from the entwine and instead connect it to, connect the cull version of it to the entwine. All right. So we did that. Super. That's our mountain fold line goal. A bit more tricky, but seems to, well, we'll see if it works, but should work. Let me go to perspective view to just check. Hit the reset button, toggle true, reset again. Okay. Moment of truth. I will start increasing the degrees a bit. And it kind of works. We're starting to see some bending happening. So that's nice. So it is working. Okay. Let me reset and stop and always keep in mind that you want to have the degrees set to 0. So what about the valley lines here? Well, it's exactly the same procedure as for the mountains, right? So I have this whole shebang here, actually, except for the degrees and the radians. Yes, except for degrees and the radians. I have this whole shebang here. I'll just group it, and I'll just make a copy of it. Copy, paste, right? And instead of mountain curves here, I'll delete that. I will plug in valley curves, like that. Right? So now everything is exactly the same as we did with the mountain curves, only that we're doing it for the valley curves. Okay, and we're culling it, and I can connect it to the 0, 1. And let's just see how it works. So as I fold it, you can see that it messes up drastically, right? And it's messing up because we're using the same angle for the mountains and the valleys, but actually valleys, all of the valley lines they need to bend in a completely opposite direction as the mountains. If the mountains are bending upwards, the valleys need to bend downwards, right? So that means that the rest angle for the valley hinge needs to be a negative version of the rest angle of the mountain hinge. And I can do that by just typing in negative, plugging in the radians into the negative, and connecting it to the rest angle of the valleys here, like so. And maybe I should just kind of, yeah, I'll just add it here, add to group. It's a bit messy, maybe something like that. Yeah, that's, I think, good enough. Okay, so this is the main one, the main thing, right? Blob outline. And actually, let me make it perhaps white or something like that. Let's see if it works. Run the simulation, increase the degrees, and it's working, but it's not, it's not great. It's cool. It does fold quite nicely, but it's not great. So now the remainder of the tutorial is going to be me explaining how to clean up your fold simulations and your meshes for folding. This is 150 degrees folding, and I can fold it back as well, I think. It's kind of messed up. Actually, it kind of folds back quite nicely, at least here. Anyway, so let's clean it up. Let me stop the simulation here, and I will make a gap between this mesh right here and this mesh right here. Well, these two mesh components, because we will be adding some additional stuff. Let me reset, and actually let me hide everything on the on the right hand side. I will enable this mesh here. So first of all, the problem is that these rectangles, we're saying that we don't want them to be stretched, right? And they are not getting stretched, that's for sure. But what's happening is, because they're you know, we are forcing them to keep the where is it hinge points, hinge edge lengths. We're forcing them, all of the edges, to keep their length, all of their lengths, right? But there's an issue with that. If I have a rectangle, right, and I say that these edges, let me explode it, and I say all of these edges need to keep the same length. What I can do still with it, and let me simplify it, what I can do with it, I can take this edge, for instance, rotate it, right? So I'm not scaling it or anything, I just rotate it, right? And that this rectangle, without changing any edge lengths, right? All of the edges are still the same length, just got skewed, just got messed up. Even worse, this rectangle can it? It can kind of twist and bend and transform in 3 dimensions. So we need to fix that. And the way to fix it, let's say this is what we want to keep. The way to fix it is to add one line here, like that, and one line here, like that, right? Since we do it this way, and we say that these lines cannot change their length. When we do it this way, we introduce cross-bracing, and cross-bracing will not let the form swivel at all. It will let it kind of bend still, but should be good enough, right? So let's try it out. So for every quad here, I will do a cross on it. To do a cross on a quad, I need this mesh. First of all, I need to get rid of all of the triangles, right? So I will take this mesh and I will ask for ViewBird extract face polylines. I'll ask for every polyline of this mesh. So every polygon becomes a closed polyline, and I will ask for discontinuities. So basically give me every corner of each polyline. And some of them will have 3 points, some of them will have 4, depending if it's a quad or a triangle. So I'll ask for list length. And I'll just flatten out the list so that you can see better. So now I have a list for every single one of these polylines. I have a list of numbers, you know, 3 points, 3 corners, 4 corners, 3 corners, 4 corners, and so on. Super. I will ask, is it equal? Is this number equal to 4, for instance? And then it gives me, I'm basically asking, is it a quad, you know, or is it a triangle? And it's basically just it's telling me yes, no, yes, no, yes, no. And with that, I can use, I could use cull, but I will use dispatch, I think. I'll use dispatch or that. Or maybe we should just use cull. Cull pattern, list, pattern, ta-da, I just removed every triangle from the equation, right? There were triangles here. Now there are no triangles. So only quads are left because I only care about quads because triangles cannot twist. All right. So now for these quads, it's gonna be kind of easy. I will just use discontinuity again on them. So I have these 4 corner points. I will say list length, list item. So I get I get first point, second point, third point, fourth point. So all 4 points, and then I will just draw 2 lines. So line between 2 points, copy paste. So I will be drawing, one here and the X. So I believe it's going to be between the first point and the third point, and between the second point and the fourth point. Yeah, perfect. So we have all of the lines here. I don't have enough room. Let me just make some room. Super. Okay, we have our lines here. Let me merge them into one big happy list and just flatten them out because I don't really care about them. So we get this pattern here, which kind of looks cool, I think. But all of these lines that I just got, they should not change their length during the simulation, right? So the mesh is going to be kind of locked, like braced with these lines. I'll go to Kangaroo, mesh, escape, no. Kangaroo 2, it's not mesh, it's goals line, length line, this one. And I'm just going to specify that, the merge, all of these lines are line input, length. If none provided, starting length will be used. Perfect. I went it that way. And strength. Can we just reuse I will just reuse the same high strength of edge lengths, of mesh edge lengths here. And holding now the shift key, I will just connect it to 0, 1. Whew. Okay, let me group this portion here and I will just call it cross brace. Okay, so we have that going on. Like that. Mesh looks kind of good. Preview, custom preview. Swatch, maybe something nicer, blue, something like that. Go to perspective view. Oh, that's way too dark. We won't be able to see anything. Maybe blue is a bad idea. Candy pink it is. Okay. So let's see this in action now with cross bracing. Start turning on the degrees. I can see some bending happening, and this is, as you can see, this is much more controlled now. And it's twisting, it's bending. It's becoming almost like a skirt for a bit. Come on. Whoop. And there we go. So it gave in, and it's basically just bending inwards. I believe this pattern breaks at around 175 degrees. Let me try 170. So I'll just change the maximum degrees to 170 just to see if it breaks or not. Or maybe not. Yeah, works quite well. Okay, so we have our origami fold pattern. And can I unfold it? You need to do it slowly, by the way. Just slowly unfold it completely to 0. There we go. Nice. Okay, so I'm happy with how it looks like. To make it nicer, from here on out, it's all going to be graphics. It's not going to be anything special. To make it nicer, I believe I went to ViewerBird, Transform, ViewerBird's Mesh Window, and ViewerBird's Picture Frame. These two components here, I just kind of connected it like so and chose the same distance. So let's try, is it 1 here? No, it's 5. Wow. Is it 1 here? No, it's 5 as well. Something smaller, 2. Something like that. Then custom preview for one of them and preview, custom preview. Swatch nicer one. For the second one, what the, oh, there we go. You know, something nicer. And you can use offset and all sorts of different things for it, or mesh thicken, for instance, you know, to thicken it up, but I will not be doing that. Instead, I will be importing a rocket, right? Because we need to actually make this, you know, look nice. NASA has done this beautiful pattern, and it would be a shame not to actually, you know, show it with a rocket. So I will, do I have any of them here? Rocket, I do. It's right on my desktop. Import file, okay. There we go. That's just a booster engine here. I believe I have a few I did have a few hidden lines there. Like that. Cell PT, just to get rid of some of the points. So I have this 3D model of an engine here, and it's basically, I just modeled it out from according to, I believe it was SpaceX Falcon Heavy booster, Raptor booster. I don't know, but I will play a quick video of how I modeled it out right now. And now we're back. So basically I have this guy here modeled out, right? So let me just rotate it in place like that and just move it to the nice spot here right in the center. I'm not being precise with it, I know, but I don't really care. I'll go to, like, I'll just move it down somewhere here. Let me just double check how this whole thing folds. Reset, run, fold it. I just want to fold it in, so to see how much of a tolerance am I dealing with. How much of a gap am I dealing with? Okay, that's good, that's good, that's good, that's good, that's good, that's good. And then it folds together. So in front view, yeah, that's actually pretty close. Could be a bit lower. Yeah, that's pretty fine. So we have something like that going on, and or actually maybe we can move it down even more and then say that there is some sort of a cargo going on in this spot here, and then I will just draw out a cylinder. So at this point I'm just modeling, and I will have a separate tutorial on how I model things ready for you guys, but for now it's just going to be real quick and dirty. So I'll just model out a cylinder, or maybe a hexagon, no, a cylinder. 0, something like that, up. Okay, and then actually I do want a polygon, 0. Number of sides, that's an 8. Something like that, and I will just extrude it. Extrude curve. So I do have quite a few tutorials on modeling prepared, and I believe those will be really cool to see, but they're still not ready. Hopefully next week. So I'll show the stuff here. So this one goes, it needs to go all the way through. So let me just increase it like so. Yeah, it's kind of touching, that's fine. And I'll actually make a copy of it upwards. Just like that. Super. Boolean difference. Actually, this one is a bit too much in your face. So maybe doing something like that will be good. Boolean difference. Cut that one out. Okay. And then this box, what are we gonna do with this box? Maybe we just scale it down. Something like this. Maybe a bit more like this. Like that. How big are you? Well, you're kind of big, but that's fine. Chamfer edge. Yeah, we can work with this. So I'll just make a copy of it. Make a ton of copies of it. That's 5. Maybe 9. Copy. Okay, 9 kinda seems to work. But you know what's better than 9? It's 18. And you know what's better than 18? You guessed it. It's 36. Okay. So I will not be designing it anymore. This is what we get. And let's see, Arctic view. That's how it looks like. We can actually go to properties, select all of these bad boys here, material, new material, metal. I'll just choose it to be golden. I don't know why. Golden, and this one can be white. Or should it also be golden? Maybe it should also be golden. There we go. Oh, that's far away from being... screw it. That's good enough. As good as it's gonna get. Okay, so we have this thing going on here, and I will call it a day. First, let's just look at how it kind of unfolds, because that's always nice to see. Just slowly. Boom, boom, boom. Deploy. Deploy. Umbrella. Wow. Perfect. And contract. I was thinking that it might break, but it's not breaking, so that's cool. Okay, so we have that, and I will... It's turnable. I will be setting this. How the heck do you... Can I... That doesn't look cool. 45 degrees. Turnable. Why did I say turnable? Turntable. God damn it. Let's make it faster. Wow. Okay. So I will call this a day. Hope you all enjoyed it, and I will see you on Sunday with another folding video, but that one is going to be more advanced and even cooler. So, see you then. Bye.